All right. Good morning or good afternoon, depending on what part of the world or the area you're coming from. Welcome to today's webinar. We know everyone has a very busy schedule in today's world, and we certainly appreciate you guys carving off some time to be with us during this webinar. We're coming to you today from YellowScan's U.S. Office, located in the Majestic Building in Salt Lake City, Utah. And my name is Cliff Holly. I'm the General Manager and Business Development Manager for YellowScan Inc., the US entity here for YellowScan. I'm also joined by Thibaud Capra.
Morning, everyone, or afternoon.
For myself, I'm a 20-year, 25-year, too many years veteran of the geospatial information industry. Having a start in GIS database development, working through various remote sensing, LiDAR, UAS type applications as well. I'm currently responsible for developing and growing the YellowScan UAV LiDAR market here for the Americas, currently to include all of North America as well as South and Central America. The presentation will actually be provided by Thibaud Capra, who's the application engineer within the company. Thibaud has a 7-year background in surveying, working with various types of terrestrial LiDAR scanning, as well as photogrammetry and, of course, aerial LiDAR applications. He's currently supporting the Americas office for YellowScan. He's here physically in the Salt Lake City office and working to support customer training, technical support, pre and post sales, and of course, importantly to this conversation today, working on benchmarking and testing the limits and capabilities of our various products. The presentation today is going to be basically talking about the different capabilities and a little bit of the differences between our products and where those applications would be best fit for certain product matchups. What I'd like to do before we do that, though, is just simply illustrate very quickly the commonalities between all of our products. YellowScan has been from day one purposely trying to produce commercially available LiDAR for UAS that's lightweight, low power, highly capable, but yet easy to use in the field as well as in the back office for software production, data production. And we have all of our units are fully integrated, self-contained, if you will, only requiring a vibration isolated mount to the particular UAS platform of your choice. By fully integrated, what we mean is that it comes complete with, of course, the laser scanner, the built-in IMU GNSS solution. It also includes the built-in computer capability to allow for onboard data collection. And of course, we also provide for onboard power. So again, it's a standalone system, no integration, perhaps, unlike a lot of others in the market, there's no required integration electronically to the unit itself or to the UAV. With this, I'm going to have Thibaud turn off the live camera. We're going to move into the presentation where he'll go ahead and discuss some of the pros and cons of different products in different applications. Thibaud?
All right, we will right away move on to the summary, or as I like to call it, what's on the menu today. We will start with systems overlook, showing you which systems will be talked about today. Then we'll move on to the real life performance comparison and then go to more detailed problem solving, such as line detection, power description, and finally ground detection with vegetation. So two main areas of discussion today. The first one being more corridor mapping and power line surveys, and the second one being ground detection. And then we will finish with a direct comparison wrap up. So first, the systems overlooked. Cliff discussed a bit about what our systems are, and our product lineup with the YellowScan all integrated sensors starts with the YellowScan Surveyor. This is a tried and proved system. It's integrating a Velodyne sensor, just like the Surveyor Ultra. The Surveyor is our most flexible and lightweight solution, while the Surveyor Ultra, also a Velodyne-based product, is our long-range and high-velocity solution. Then we move on to the VX series with the VX15, VX20, and VXDL. The VX15 and VX20 are the high precision and especially the VX20, the high accuracy system. And the VXDL is the high speed, high precision system. All the VX series are integrating Regal sensor. Yes, Cliff?
I'm just going to jump back in here real quick before we get any further into the slides and just point out that obviously today we're on transmit mode from our side. You guys are in receive mode only for audio. If you have questions, please, absolutely, we want to address as many of those as possible today. Please go ahead and use the question tool in the application, and we'll either answer them at the end of the session or fit them in during the topic of discussion. Thank you.
Yes. Do not hesitate to ask any question regarding what you see in the slides. If it's some detail that I forgot, for example, or if it's a question for later, we will answer it either right away or at the end of the presentation. So for our sensors, I will go a bit more into the details now. I will start with the Surveyor. So the Surveyor, as I said earlier, is a Velodyne integration. It's the VLP16, also very well known as the puck. It's combined with an integrated APX15 IMU from Applanix. It weighs with the battery 1.6 kilograms with a precision and accuracy at nadir at 50 meters of 4 centimeter precision and 5 centimeter accuracy. Typically, you want to use this system at about 50 meter flight altitude. It is shooting 300,000 points per second, split it in 16 different beams, hence the name VLP16, with a number of echoes of 2. Typically, you want to use this tool kind of as a Swiss Army knife, as it is a very flexible and lightweight system. We now stay in the Velodyne family, but we move on to the Surveyor Ultra. So the Surveyor Ultra is an integration of the Velodyne VLP32C. As the name suggests, it's a 32 laser beams system from Velodyne, also known as the Ultra puck. It is integrated with an APX15 IMU from Applanix. The system weighs with the battery 1.7 kilograms. Your precision and accuracy at nadir will be between 5 to 10 centimeter with the Surveyor Ultra being a bit worse as you go up, so you'll get closer to the 10 centimeter mark. Typically, you want to fly this system at 80 meters, and it has a range of over 100 meters, and we'll see the consequence of that. It is shooting, compared to the Surveyor, it is shooting 600,000 points per second, so twice as much, with these 32 laser beams being splitted a bit forward and a bit aft. It has still 2 echoes, and typically you want to use this system for high velocity surveys. Now we move on to the VX series. So as I said earlier, the VX are Regal integration. So first we're looking at the VXDL. DL stands for downward looking. It's a Minivox 1DL integration combined with the higher grade APX20 IMU from Applanix. This is our heaviest system with a 4.1 kilogram total weight with the battery included. But you're looking at way better precision and accuracy numbers. You're looking at 1 to 2 centimeter precision and 2.5 centimeter accuracy at nadir at 50 meters. Typically, you want to fly this system at 60 meters with a range of about 100 meters. Being a Regal sensor, it's very famous for its number of echoes too. It has 5 echoes. It is shooting 100,000 points per second, but focused and channeled downward looking. So typically, this is the superstar of the corridor mapping, really. Now we move on to the YellowScan VX series. So the VX are the Minivox 1 integration from Regal still. It's coming in 2 different versions. One is integrating the APX15 IMU, and the other one is integrating the higher grade APX20 IMU. Both are still from Applanix. So the APX15 version will give you 2.5 system weight, 2.5 kilogram system weight to get still with the battery included, with a precision of 1 to 2 centimeters and an accuracy of 5 centimeters. On the other side, the VX20 will give you a system weight of 3.1 kilograms with the battery, still have that precision of 1 to 2 centimeters, but because you have that higher grade IMU, you will have a better accuracy of 2.5 centimeters. Typically, you want to fly this system at 80 meters, and the range of the sensor itself is more than 100 meters. We'll see the consequence of that. So, being a Minivox, it's shooting still 100,000 points per second. With you have to keep in mind that it's 360 degrees. Typically, you want to use this system for high precision works. For example, civil engineering is a good application for this system.
Just jumping in, we've got one question here I want to throw in. Can any or all of your systems be used for small manned aircraft applications? I'll let Thibaud get into maybe more detail now or in further slides, but I will say that certainly we have products that are currently geared towards UAV fixed wing solutions better than others. And it's a lot of that's to do with the scan rate and the speed of data collection. I know that Thibaud has some information further on in the slides. As far as manned aircraft go, the only real consideration to be considered with is the lower AGL flight altitudes that are limiting by the laser power. So, you know, you're looking at maximum of 100 to 120 meters AGL. Even with the DL, you wouldn't even want to fly too much at that height even. So I would suggest that probably not really, none of our products are really geared towards light small manned aircraft.
All right. So now that we've seen a bit more of our systems, we will focus more on the 3 that are circled here, because they have more similar capabilities. The Surveyor is more of a flexible tool, and the 3 on the right fit in kind of similar applications potentially. So first, we'll look at the point density at 100 meters above ground level at 5 meters per second. You can see that both the VXDL in yellow and the Surveyor Ultra in black stay reasonably above the 150 points per square meter, while the VX is staying above 25 points per square meter. This is due to the shooting rate and how the points are channeled. When you look at higher speeds, like 18 meters per second, which is typical for fixed wing UAV or VTOL UAV, you're staying pretty solid above the 40 points per square meter mark for both the DL and the Ultra, and the VX is below 10 points per square meter. We now move on to the real life performance comparison. First of all, I want to talk about the field of view. I saw that we have a question about the system SWAF. I'll move on in a few slides to it, don't worry. So first of all, the VXDL has as explained, a limited field of view of 46 degrees channeling all the points per second into that cone. So when you're surveying, you'll only have a limited field of view that cannot be modified. So basically, for example, here, when flying above a power line, you may not have the whole picture of what's around it. For the Surveyor Ultra and the VX, the scanner is scanning at 360 degrees with a typical field of view opening of 120 degrees that allow you to see more about what's around it. So we move on now to the swath of the system. Here, this example was taken at 100 meters AGL for the Ultra, and you have about 300 meters swath. When we move on to the VX, you have about 400 meters of a usable swath, still at 100 meters. For the VXDL, the test was done in a different site at 80 meters, and you can see that you have about 50 meters swath. Regarding the data quality, first we'll look at the Ultra with a precision of about 10 centimeter. Just want to remind you that it's shooting 600,000 points per second, hence the very, very dense number of points pretty much everywhere. Here you can see that you can clearly see what's surveyed. It's a tower, a power line, but the point cloud is a bit noisy. When we move on to the VX, because it's shooting less points per second, you can see that the data is less dense, but because of that higher precision, the point cloud is really less noisy, and overall it's a higher quality. When we go to the DL, you kind of get the best of both worlds, because all the points that it's shooting are focused downward looking. So you get that very high density while still keeping the well-renowned regal precision of 1 to 2 centimeter, resulting in a less noisy point cloud. I just want to mention that with the DL, because of that limited field of view, not flying directly above the line or too low can lead to cuts in your final data. So you will need multiple passes to make sure all the data is acquired. We now move on to more individual problem solving. So first of all, we are talking about line detection. So with the Surveyor Ultras, the lines can be detected. You can see that it's very well described. It's very dense. Double canaries can be an issue to discriminate due to that noise. The vectorization then can be automated, but may require manual adjustment for dual canaries, for example. When we look at the VX, you can see that the lines are easily detected, but even double canaries are clearly discriminated. So the vectorization is straightforward and easily automated. For the VXDL, the lines are easily detected thanks to that density. Even double canaries are clearly discriminated, and that results in a straightforward and easy vectorization automatedly. Now we move on to another problem that could be the tower description. So first we start with the Surveyor Ultra. You can see that the tower is heavily described. The tower insulator connectors are visible. You can clearly see them, and it's a good description of the tower. When we move on to the VX, you see that the tower is still described. The tower insulator connectors can be a bit challenging, but it's a good enough description of your tower. For the VXDL, the tower is well described. The insulator connectors are clearly visible, and it's a great description of your tower. Now we move on to a kind of a different world, which is the ground detection above vegetation. It's a well-known feature of LiDAR that it can penetrate vegetation. This is due to the echoes because it's an active sensor. So first we move on to the Surveyor series, kind of, well, still a focus on the Ultra. So the ground is well populated. The fact that it has a 2 echo system, it helps marginally. The fact that it's scanning at different angles helps a lot, and the shooting rate of the system helps greatly. You still get good results at 100-meter AGL with the Surveyor Ultra, and it's usable for DTM generation. When we move on to the VX, the ground is populated enough. The fact that it has a 5 echo system helps up to the 3rd echo. And you have good results even at 100-meter plus AGL flight heights, although the best results are at around 80-meter AGL. It is very much usable for a more precise and Z value DTM generation, as you can see here. And it's still a very good system for this. We move on now to the VXDL. The ground is well enough described. The fact that it still has that 5 echo system helps up to the 3rd echo still. The fact that it's having different scanning angles helps a lot. But due to that limited swath, you have a low coverage in one flight line. So to survey an area that's not linear, you might require multiple flight lines, even for small areas. The data is very much usable for a DTM generation. And that concludes our individual system study. So now we move on to the direct comparison wrap-up. First, I want to still stay a bit on the vegetation penetration. And here are 3 key factors that will improve your vegetation penetration. So first, we're talking about echoes. The ground points, they come from different echo number. If you have a first echo or first return, that means that you had direct line of sight from the sensor to the ground. The echoes are relevant up to a certain point, 3 echoes being ideal, because the 4th and 5th echo, the intensity of the return is so thin that it's sometimes hard to detect for the sensor. And that's why the laser power also impacts the capacity for your echo detection. As for the number of laser beams, a multi-beam system with the forward and aft opening angle will compensate a fewer number of echoes, but not fully. But on the other side, the amount of shots per second it will enable will increase your odds of hitting the ground. So having more shots per second will overall give you better results. And lastly, it is very important, it's the flight planning. If you fly too fast, too high, or too low, it will impact the capacity of penetrating vegetation. What I mean by that is that there is a sweet spot for each sensor about where it's ideal for it to be flown to penetrate vegetation efficiently. Lastly, I want to mention that multiple flight lines will bring different viewing angles. So having flight lines in different directions can be very interesting too, and will maximize the odds of a good description. Now, if we move on to our product lineup that I mentioned earlier, so the Surveyor Ultra will have a very high productivity regarding the vegetation encroachment analysis, because in one pass you will, thanks to that big swath, survey also what's around your power line. For the VXDL, it is very much capable of doing very good things in corridor mapping. In fact, it's optimized for it, but in multiple passes to avoid cuts in your data. For the VXDL, it is capable of doing that vegetation encroachment analysis as long as you don't fly too fast. Now, for DTM construction, rehab work type of jobs, all systems are capable of giving you DTMs. Each sensor will give you different quality of DTMs. The VX series will have a higher precision. For the line sagging analysis, as long as you can vectorize your line, which is the case with every sensor, you will be capable of doing it. For large area mapping, I would say that the Surveyor Ultra will be very good because it covers a lot of ground and you can fly fast. With the VXDL, you have a lower productivity due to that limited swath, so you will have to fly more flight lines to cover the same area. And for the VX, you will have that capability, of course, with a lower density, but with a higher precision. Back to the power line tower description, all systems are perfectly capable of describing your power line tower, the VXDL being the best at it, because you have that density and the quality of the data. Regarding the power line vectorization, every sensor can do it. The Surveyor Ultra, you're looking at potentially some manual editing and verifications. The VXDL is really good as long as you're careful on flight planning, and the VX is capable of doing it. For any type of earthworks management, every sensor can do it. The Ultra being the best productivity-wise, but not the best quality-wise. The VX will provide you with the best quality for this. Lastly, I want to mention the high-speed capability. The Ultra and the DL are tailored towards high speed due to their high shooting rate and good density. And the VX should not be used at high speeds. That concludes that presentation. If you want to meet with YellowScan, we will be at Energeo in Stuttgart in mid-September. You can find us at booth 36 in the hall A3. And the American team, Cliff and I, will be here at the Commercial UAV Expo in the Westgate Casino Resort in Las Vegas, late October, and you can find us on booth 625. I think we will turn back the webcam on.
Yeah, we can go ahead and do that now.
And move on to the questions. And we're back.
So I know we're getting close to the end of the half hour here, so we do have a few minutes for a couple of questions. A couple that have come in that I'd like to address if we can. One is on a technical side, one's on a sales side. With regards to the VXDL, would a typical down and back flight pattern in what we consider regionally to be a fairly standard corridor width of 200 feet and appropriate flight height, would a VXDL provide adequate coverage for that conductor set inside of 200 foot corridor down and back?
Okay, so 200 foot in meters is about 80 meters. Right?
Yeah,
80 meters. So yes, that should do it into path.
Okay.
You got to be careful not to fly too much on the side of your power line,
Right.
because we've seen that cutting effect that it can have. But overall, yes, in two ways like this, one on each side should be good.
Perfect. And the other question that was more sales related was, are there sales partners or distributors in the region? Yes. Right now we are, better covered currently in the North American region, where we have a regional partner in Canada by the name of Jenny Drone. We have two partners currently in the United States, Juniper Unmanned out of Colorado, and a new, to be honest, actually as of yet unofficially announced, new partner by the name of Frontier Precision, representing primarily the northwestern quadrant of the United States. I would say be watching our website. All of this information can be found there, but we should very soon be adding Latin American partners as well, as we bring new internal staff on board in the next weeks to address Latin America as well. Any other questions that's come in?
So I see, can you talk about cross cable section accuracy? So cross cable section is going to be hard to determine because you're basically only measuring the top of your cable. If I understand your question correctly, right? Because you're measuring only the top of your cable, and usually for most systems, the precision is within the cable thickness, basically. I have another question, but it's longer than the column. So, what type of UAV do you recommend for the Ultra, and what other accessories would be needed? Oh, there's a lot of questions coming in. Let me clean a bit. Okay. What type of UAV do I recommend for the Ultra? Well, it will depend on the types of projects that you want to tackle with the Ultra. For corridor mapping, usually you want to cover more ground in one flight, so that's more towards, I would say, fixed wing or VTOLs types of UAVs. We have integrated nose for the quantum systems Tron, Tron, just like the movie. That is a perfect fit for the Ultra. Regarding the accessories, you will need a base station for PPK processing, and that's about it, because the system is self-contained and comes even with the software to process your data and generate .las files.
I would add to that, as far as the accessories go, that of course, depending on the platform, well, regardless of the platform, you're going to need some type of an integration solution for the LiDAR to the UAS. In the instance of the DJI Matrice 600 series, we have internally developed a very nice quick release mount system with vibration isolation that's satisfactory for our LiDAR operations. We've also extended that mount to include the opportunity for an optional single nadir looking Sony Alpha 6000 camera, as well as a dual stereo, sort of an inwardly oblique looking stereo set of cameras as well. So, you know, we're flying successfully all of our platforms, all of the LiDAR products with both single and dual cameras in various user locations.
Then we move on to the next question. Which LiDAR is best for tree height detection? So if you don't need a precise measurement, I would recommend the Surveyor Ultra. It has a very good range, so your height is safe. You're safe to fly. Sorry, high up above the trees. You will be able to detect the crown of the tree, have some information about the biomass, and then the ground, so you can have your tree height pretty easily.
With regard to the question of using the LiDAR for archaeological mapping and structure modeling, I would suggest...
there is a very good article on our website where our sister company, L'Avion Jaune, did an archaeological survey in Corsica, which is a beautiful island south of France, with the VX20. I would recommend this system for this type of project, because you have high accuracy.
I'd suggest, more importantly too, we can send you a couple of articles and use cases on this particular application for archaeological use of the LiDAR tools. We'll send those to you offline, obviously. So moving on to the next one, is there something I want to make sure we're not holding everybody up for too long here, but
so regarding a question for the use of our systems in larger UAVs, such as the Albatross UAV or Applied Aeronautics, I am not familiar with any of these two UAVs, but our systems are pretty much drone agnostic. You have only 4 screws, 2 on each side here, to attach it to the drone, and you got to be careful about vibration insulation. That's the key part for a good integration in any UAV. and that's it. We're pretty much drone agnostic. So I would say it's doable as long as you have proper vibration insulation. Which post-processing software is used in all these LiDARs? So we developed our own software, which is the YellowScan Cloud Station. You can find a demonstration of it in our YouTube channel, or just email us and ask for it. It's allowing you to generate your LAS point cloud. Now, for the trajectory processing from the IMU, we are sticking with a Planix POSPEC UAV software that allow you to refine your trajectory and then combine it with the laser data in our software to generate your final product.
I think we've got time for maybe one more question. Just as a note, any questions that we don't get a chance to address here today, we will address offline. I'll make sure that everyone on the attendee list gets a response with regard to the questions that were not addressed today.
If you have also any question that you think about later, you can still email me. You have my email address right there. It's thibaud.capra@yellowscan-lidar.com.
Okay, let's take one more here, and then yeah.
Which LiDAR to use for mapping coastal zone and calculate changes in volumes? So first of all, I want to say that because our LiDAR are based on infrared light, they do not penetrate water, so you have to be careful with that. But we have sensors that have been used for coastal erosion. There's another article on the website about this, and we can send you a use case about it where I think it was a VX20 that was used, but I also did it on a pilot project with a Surveyor. So pretty much any sensor can be used. It will depend on, I would say, the area. If you have tall trees that are close to the coastline, I would not recommend using the Surveyor because landing in the tree is never good. Unless you want to prune the tree somehow, but I would not recommend it. So it's more about the flight safety there than which system. The Surveyor is very good. It's flexible, so any system can be used.
I'm going to address one last question myself, and then we're gonna have to wrap it up for today. The question is, what processing alternative exists for matching flight lines besides TerraSolid? For those that are familiar with us at YellowScan, obviously TerraSolid is a solution that we recommend. It's one that we're comfortable with. It's one that we know well. It's one that's worked well for us. Obviously, there's other platforms out there that you can use. What I'd like to address is just kind of a standby, if you will allow us to make an introduction later on this fall at some of the meetings. I think you'll start to see some internal activities that are ongoing within YellowScan to address different types of methodologies for getting line matching done. One that I can speak of more directly today is actually via our partner at Planix through their POSPAC solution. They've now got a LiDAR QC application, which will take the LiDAR data set itself into consideration as it's working its trajectory correction algorithms, and then reinserting that back into the final trajectory corrections. We're finding it's brand new, just barely out on the market, but so far we're seeing
for 2 weeks now.
Yeah, we're seeing good results from it so far. So if you're interested in more details on that, reach out to Thibaud. I'm sure he can fill you in with how to get a license, maybe a demo is available, etc. So with that, there's a lot of other questions I'd like to go over, but I think we're going to have to cut it short today. Thank you all for joining us this afternoon or again this morning. I do want to mention that this session was recorded. The link for that recording will be sent out after the session is completed. We also have a survey that's going to go out to the attendee list. any input, positive feedback, anything that you can give us is very much appreciated. And with that, I think we are at our end.
About done. Yeah, thank you all for attending.
Thank you, guys.
And feel free to ask any question to me directly, or contact us if you're interested in our products at contact@yellowscan-lidar.com.
Perfect. Take care.
Bye.